let us determine the ultimate load acting on beams DE. So this one, DE and EF. Then girders BEF, and ABC using NSCP load factors of 2015. So from this problem, we're going to consider dead loads and live load. Okay, so for dead load and live load combination, the NSCP 2015 load factor would be 1.2 for dead load plus 1.6 for live load. Okay. Now, first is we have to identify muna kung ano yung klaseng slab meron yung bawat isa. Okay? So that we could identify kung one-way slab ba siya or two-way slab. Okay. So let's start with this slab. So check slabs. Okay. Una, let's say slab ABDE. Okay, so let's solve for the ratio of the shorter over longer span. So the shorter span is 2.5 over longer span. So that's 2.5 over 6. So that is 0.41. So that is less than 0.5. Therefore, it's one way. So kung one-way slab yan, paano yung distribution ng load natin dyan? So it would be something like this. So hatiin lang natin sa gitna. Kung 2.5 yan, hatiin natin sa gitna. Kasi one-way distribution lang. Ayan. So di bali, yung kalahati ng rectangle, yung 1.25 by 6, mapupunta sa beam na to. No? So ganyan siya. So yung area na to would be transferred doon. Tapos yung another half naman would be transferred sunod sa beam DE. Okay, so that's one-way slab. Next, how about BCEF? BCEF. So M is equal to S. S is 2.5. Shorter span over longer span is 4.8. Okay, so 2.5 divided by 4.8. So that is 0.52. That's greater than 0.5. Therefore, it's two-way. Two-way slab. Okay? So, two-way slab. Okay, how about this one? DEGH. So that is M. Shorter is 4 meters over 6. No? So 2/3. So 2/3 is actually 0.67. Okay, so that is greater than 0.5. Therefore, two-way slab din siya. Then lastly, for this slab, EFHI. Okay, so that's M is 4 over 4.8. 4.8. So the ratio is 0.83. Again, that's greater than 0.5. That means it's a two-way slab. So all the remaining slabs are considered as three-way. So paano ang three-way? Diba pagka three-way, ang ginagawa natin is we draw a 45 degrees. So 45 degrees. So let's say here. So there you have the 45 degrees. Okay. Okay, so that will be the distribution of load. So meaning to say, For this beam DE, di ba rin meron siyang trapezoidal load. Yan yung load or yung tributary area for DE. For GH, you will have this trapezoidal tributary area also. While for beam DG, meron siyang triangular lang. Triangular tributary area. And likewise for EH, meron siyang triangular tributary area. So same thing din dun sa dalawang slab. So like let's say for BE, you draw a 45 degrees, 45 degrees, 45 degrees, 45 degrees, then you, okay, dito naman, ganun din, we have 45 degrees, 45 degrees, then 45 degrees, 45 degrees, okay, so that's it, no? So we have one way and we have three ways, two-way slabs. Okay, now what's next? We're asked to determine for the loadings on DE. Okay, so pagka sa beam DE, ang load niya would be isang rectangular galing dito sa slab na to and trapezoidal load from here. Okay? For EF naman, okay, for EF naman, ang load dun sa EF naman would be trapezoidal galing doon, tsaka trapezoidal din galing doon. I-add mo lang silang dalawa. Okay? So, before we do that, we have to solve first for the floor area. Okay, so let us solve first for the floor area. Floor loads rather. So, what are the floor loads? Okay, so the floor loads would be divided to, una, syempre, would be the dead loads. Basically, yung mga dead loads will be coming from the self-weight or yung mga materials on top of the slab. Okay, so these are the dead loads for the slab, beams, and columns. Okay, so ano ba yung mga kinakarga ng mga beam? So let us consider the beam muna. Beams and girders. Siyempre may self-weight siya. Okay, so una. So let us consider beam self-weight. Okay, so what's the beam self-weight? Okay, for the beam self-weight, since the beam is made of a reinforced concrete, so titingin lang tayo sa NSCP. Yung previous problem natin or yung video lecture ko, yung specification of materials were taken from the book of Hibbeler. So sa US yun. So this time, let us apply this based from the NSCP, the National Structural Code of the Philippines. So Philippine Setup. So sa chapter 2 ng NSCP, makikita nyo itong mga table na to. Okay, yung first table that I'm showing you right now are the minimum density for design loads for materials. Okay? So since made of concrete siya, hanapin lang natin yung concrete dito. So ito, we have this concrete and we'll be considering reinforced concrete, so with reinforcement. Okay, so ito, stone including gravel. So we will be using this one value, 23.6, that is kilonewton per cubic meter. So again, this is kilonewton per cubic meter. Okay, so that's the density. So from here, so I'll be using 23.6, that's kilonewton per cubic meter. Okay, now I want to solve for the load on a beam. So ibig sabihin, dapat ang load ko ma-express ko in terms of kilonewton per meter. Okay, so ang gagawin ko is I'm going to multiply this density, kilonewton per cubic meter, with the cross section of the beam, and the cross section of the beam is 250 by 500. These are millimeters, i-convert ko lang siya sa meter para maging consistent dito. So 250 mm is 0.25. So 0.25 meter, tsaka yung 500 mm is 0.5. Okay, meter. Okay, so that would give us So that will give me the value of the beam self-weight, 23.6. So tandaan nyo na yan, no? Density of reinforced concrete yan, 23.6 kN per cubic meter. So times 0.25 times 0.5. So I got 2.95. That's kilonewton per meter. So uniform load na siya para sa beam due to the self-weight. Okay. So what else? Aside from the self-weight, meron daw superimposed loads. Superimposed load meaning these are the load on top of the self-weight of the member. Okay, so aside from the self-weight, meron daw siyang floor finish. Okay, isa-isayin natin. Okay, so floor finish. So titingin ulit tayo sa Chapter 2 NSCP. So makikita nyo rin tong table na to. Okay, so NSCP 2015, minimum design dead loads. Tapos meron din ako ditong 2015 minimum design live loads. Okay, so since floor finish is a dead load, hanapin natin dito floor finish. So where is the floor finish? Ito, floor finish. Okay, ano ba yung description ng floor finish natin? Okay, ceramic daw, tapos 1/2 inch yung mortar. Ganun kakapal. Okay, yung 1/2 inch, 1/2 inch is kalahati na, diba 1 inch is 25.4. So 25.4 ang 1 inch, kalahati nun, 25.4 divided by 2. So that's around 12.7 millimeters yung 1/2 inch. Okay, so hanapin natin yung floor finish na ceramic. Floor finish, ito, floor finish na ceramic. Ito, ceramic. So we have here ceramic finish, 25 mm. Okay, so ito naman, ceramic 12.7 mm. So that's around, ito yun, yung 13. Ito. Okay, so ceramic or quarry tile on 13 mm mortar bed. Okay, so 1/2 inch mortar is equivalent to 12.7. So most likely ito yun, 13. Ito yun, 13 mm mortar bed. And that is 0.77. Okay, 0.77. Okay, so 0.77. Ang unit niya is kilopascal. Kilopascal is actually kilonewton per square meter. Okay? Yan. Kilonewton per square meter. Okay. Ito na yung floor load niya. Floor load. So this is based from the tributary area. So we will consider it later based on the tributary area. Okay, floor finished. Next is we have ceiling wood fairing. Okay, ceiling with wood fairing. So ceiling wood fairing. Ceiling. So nasa yung ceiling. Ito, ceiling. Tapos ang ginamit daw is wood fairing. Ito. So this one. Okay, wood fairing suspension system for ceiling. So 0.12. 0.12. So again, letter C. This is for ceiling. Okay, so wood fairing. Okay, so according to the table, so that is 0.12. Ito yun, 0.12 kilopascal. So that's 0.12. Kilopascal is again kilonewton per square meter. So that is another floor load. Okay, so floor load. Now, next is we have the gypsum board using 1/4 inch thick. That is also for the ceiling. Okay, so that is the gypsum board. Okay, so gypsum board. 1/4 inch daw, 1/4 thick. Okay. So nasaan yung gypsum board? Gypsum board per millimeter ito. So we have this gypsum board for ceiling which is 0.008. Kaya lang this is per millimeter thickness. So that is 0.008 kilopascal, kilonewton per cubic meter, square meter. That's kilopascal. Kaya lang this is per millimeter thickness. So imumultiply natin to kung gaano kakapal. So ang kapal niya is 1/4 inch thick. This is inches. 1/4 inch thick. Okay? So that would be 1/4. Kaya lang inch. So para siya maging consistent, meter square tapos inch. So i-convert natin muna. Ano ba? So 1 inch is 25.4 millimeter. Tapos yung millimeter, 1 meter is 1,000 millimeter. Okay? So di bali ilan yung pinaka gypsum board natin na weight. So 0.008 times 1/4 times 25.4 divided by 1,000. Okay, so that is point. Okay. So this is ano ba? Wait lang, check natin ulit. So this is inches. 1 inch is 25.4 mm. Then 1 meter is 1,000 millimeter. So 0.008 times 1/4 times 25.4 divided by 1,000. Okay? So that is 5.08 times 10 to the negative 5 kilonewton per meter. Okay? Wait lang, sorry again, my mistake. So as stated in the code, this 0.008 kilonewton per meter square is per mm. So this is per millimeter. Okay, so ang gagawin na lang natin dyan is imumultiply natin siya ng ilang millimeter ba yung 1/4 inch. Okay, so the total would be 0.008. So ilang millimeter ba yung 1/4 inch? So times 1/4. Kaya lang this is inches. Convert na lang natin siya sa millimeter. Inch is 25.4 millimeter. Okay? So para maging millimeter. So that would be the total weight for the gypsum. So 0.008 times divided by 4 times 25.4. Ayan. So di bali ang total na is 0.0508 kilopascal. Kilopascal is kilonewton per square meter. Yung 0.008 kasi is yan yung gypsum board weight kapag ka 1 mm yung thickness. 1 mm. Since ilang mm ba yung 1/4 inch? Diba ito yon? So since ito yung total mm, so i-multiply natin yung 0.008 nung total thickness niya. So we got 0.0508. Okay, ceiling. Ano pa? Okay na, ceiling gypsum. So okay na tayo, no? So okay na tayo dyan sa floor finish, tsaka yung floor finish ceramic tile, yung ceiling gypsum board, parang ganoon. So itong dalawang to flooring, tapos itong dalawang to ceiling. Next is partition naman. Okay, letter D. How about for the partition? Okay, so the description of the partition used is, it is a wood with studs with gypsum board. So hanapin natin yan dun ulit. So dun sa table. So partitions. So ito naman yung partitions natin. Okay, so pag sinabing movable partition, considered yun as live load. Dito wala namang nakaspecify kung movable yung partition. So we will consider it as a dead load na lang. Okay? Partition wood stud with gypsum board. Nasaan yun? This one. Okay, so wood or steel studs, 13mm gypsum board on each side. So most likely ito yung pinaka kaparehas niya. Okay, so that is 0.38. So I'll put it here 0.38, 0.38. That's kilopascal again, kilonewton per square meter. Okay? So mapapansin mo lahat yan, no? Kilopascal, kilonewton per square meter, except yung self-weight. So what else pa? Ito pa, yung CHB wall. Ito, yung CHB wall. I-separate natin yung live load mamaya, no? So ito muna, CHB walls or masonry walls directly placed on top of the beam. Okay, CHB stands for concrete hollow blocks. Okay, concrete hollow blocks. Okay, so let's say, so point E, CHB or masonry wall. Ito yung hollow blocks natin. Okay, so as you can see, it is directly placed down on top of the beams and girder. So ibig sabihin, kung nandyan yung mga beam mo, exactly nandyan yung CHB wall, nakapatong sa mga yan. Okay, so kung ito yung mga beams mo or girders mo, exactly directly on top of this, beams and girders, nandun yung masonry wall. Okay, so hanapin natin yung masonry wall. Masonry wall. So ito yung masonry wall natin. Okay, so ito yung masonry wall natin. So the thickness is 6 inches. Diba diba yung masonry wall natin, yung hollow blocks natin, ganyan itsura niya. Tapos may kapal siyang ganyan. Tapos diba may hollow dyan, may butas. Doon pinapasok yung palaman. Okay? So ito raw, ang thickness niya 6 inches. So ito yung 6 inches. Okay. So hahanapin ngayon natin dito. So kung mapapansin mo sa table, 100, ito yung thickness, yung width thickness, 100, 150, tsaka 200. So 6 inches is 150. So ito tayo, 150. Tapos tatlong klase yan. Ito yung lightweight density, ito yung medium weight, tapos ito yung normal weight. So dito tayo kukuha normal weight. Okay? So normal weight. Okay. So tapos ang gagamitin natin yung full. Ibig sabihin ng full grout, papasakan natin ng semento, ng konkreto, yung mga butas, yung mga cells. I-fill in natin yan. So i-full grout na natin. Okay, full grout. So full grout, tapos normal weight concrete, tapos 150 yung kapal. So di bali dito tayo 2.97. Again, 150 yung thickness kasi 6 inches given. Tapos sa normal weight tayo kasi ito lightweight, medium weight, normal weight. So sa normal weight tayo ng concrete hollow blocks, tapos full grout, ibig sabihin pupunuin natin yung lahat ng mga cells. So we got 2.97. Okay? So 2.97 kilopascal. 2.97. So we got here 2.97 kilopascal. Kilopascal or kilonewton per square meter. Kaya lang, this is directly placed down dun sa mga beams and girders. And yung height niya is 3 meters. So i-multiply natin siya ng taas ng wall. So that is 3 meters. So what we got is 2.97 times 3. So here we have 8.91 kilonewton per meter na siya. Okay, 8.91 kilonewton per meter na siya. So kung mapapansin nyo, among sa mga dead loads, yung self-weight at saka tong CHB masonry wall directly naka-apply sa beam and girder. Kaya siya kilonewton per meter parehas. Pero yung letter B, letter C, letter D, lahat tong yung tatlong to naman is in kilonewton per square meter kasi hindi naman siya directly naka-apply dun sa beam but rather sa area. Okay? Okay. Now, then, let's proceed now for the live load. Okay. So, for the live load, sabi sa problem, the live load is office. Ibig sabihin, yung paggagamitan ng frame na to is for office occupancy. Office. Okay, so anong live load? Okay, so for the live load naman, so since this is for office occupancy, so we have this table from the NSCP again, chapter 2, for the minimum design live load. So nakalist lahat dyan, yung type of occupancy. So hanapin lang natin dyan yung office. Okay, so ito yung office. So anong klaseng office? Call center ba siya for BPO? 2.9. Or for lobbies and ground floor corridors, 4 point something. Or other office. So dito tayo sa other office kasi wala namang nakaspecify doon sa problem ko anong klaseng office. So we'll be assuming it's a regular office. So for other office, the live load is 2.4 kilopascal. Likewise, nandito rin yun, no? So tignan nyo, access floor system. Ito yung office use. Pag office use, 2.4 kilopascal din. Okay? Pagka residential naman, ito, ang residential, usually 1.9 kilopascal. Okay, 1.9 kilonewton per square meter. So again, for office, we will be using 2.4. So this is 2.4 kilopascal, that's kilonewton per square meter. Okay, so tapos na, no? Tapos na lahat ng mga loadings. So we're now ready to calculate for the load dun sa mga beam. So let us start with beam DE. Okay. So beam DE. Okay, for beam DE, ito 'yon. Okay, so I will just assume that beam DE is a simply supported beam. So ito yung D, ito yung E. So the span of beam DE is 6 meters. Okay, so 6 meters. Then ano yung mga loads? So isa-isay natin. Okay, una, I have the beam self-weight. Okay, so the beam self-weight. Okay, the beam self-weight. So which is 2.95 kilonewton per meter. Okay? Tapos, meron tayong CHB wall which is 8.91. 8.91. So parehas ko silang i-add kasi parehas naman silang kilonewton per meter. Self-weight, tas ito CHB. Okay? Okay, so tapos i-add natin yung ito yung directly to sa beam. Tapos i-consider naman natin yung galing sa tributary area, sa floor area. Okay. So since this is dead load, so pagsamahin ko na, no? So times 1.2 for dead load. The load factor 2.95 plus 8.91 times 1.2. Okay? Then for the floor area, for the floor load, so separate ko na lang naman. Okay, so solve ko muna yung floor load, no? Floor load. What is the total? Floor load. So the total floor load would coming from the floor finish. Okay, so ang mga dead load 1.2 times the floor finish is 0.77. Okay, 0.77. Tapos ceiling 0.12. Tapos yung gypsum board, ito 0.05. Okay, so basic at saka partition 0.38. So pinagsama-sama ko yan lahat ng dead load. These are dead load na lahat floor load. Floor load, sabihin lahat sila kilonewton per square meter. Tapos yung 1.2 is the load factor for dead load. Tapos 1.6 sa live load. So plus 1.6 sa live load. Yung live load natin is 2.4. Okay, again, live load to. Again, lahat yan are expressed in kilopascal. 0.77 plus 0.12 plus 0.0508 plus 0.38 yan times 1.2 load factors plus 1.6 of 2.4. So we got 5.42496. Again, that's kilopascal or kilonewton per square meter. Okay? So pinaghiwalay ko silang dalawa kasi ito directly naka-apply sa beam eh. Nakapatong siya directly sa beam. Yung self-weight at saka yung HB. Ito hiniwalay ko kasi ito ito yung mga load na floor load. Nakapatong sa area, tributary area. Okay? So now, so i-compute natin muna yung una. So what are the tributary area? Okay, what are the tributary loaded areas? Diba yung una, ito yung member DE, meron tayong rectangular section dito. I mean rectangular area here. So, di bali ito yung beam natin, yung DE, say assume simple supported. Okay? So, tapos ito yung area. Okay? So that would be, ano yung unit ng uniform load dito? That would be 5.4 2496 kilonewton per square meter. Para siya maging uniform load, times natin siya ng width ng rectangle. So yung width ng rectangle dito is kalahati ng 2.5. So 1.25. So 1.25 meters. Si di bali ang total uniform load dyan 5.4. So store ko to sa A para magamit ko mamaya. So times 1.25. So I got 6.7. 12. Ang unit niya na kilonewton per meter na siya. So, pwede ko na yung i-add dun sa 14.232 kasi parehas na silang uniform load dun directly na naka-apply dun sa span ng beam. Okay? This is based from the rectangular tributary area. Now, what about the area dito sa trapezoid? Okay, so ito yung rectangular. Okay, so ito yung rectangular. Next is, we're going to consider naman yung trapezoidal. Okay, trapezoid. Trapezoid tributary area, ito yun. So, this portion. Okay, so, this is the trapezoidal tributary area papunta sa DE. So, again, so if this is our DE, so ito yung DE, 6 meters yan. So, meron siyang trapezoidal tributary area. Ito yun. Okay, so yung load naman dyan is, ang W natin dyan is 5.424 92. So that is the floor area coming from here. No? Kilo Newton per square meter. Now, so medyo komplikado or mahirap mag-analyze na ang load natin is a trapezoid. Diba? So now, what ang gagawin natin is, i-convert ko na lang to its equivalent. Convert to, okay, so rectangular, yung equivalent rectangular niya. So ito yung beam DE. So yung this is the length, which is 6 meters. I-convert ko siya sa equivalent na rectangular. Okay? And paano kino-convert yun? So sabihin ko as W1. Okay, so may formula tayo to convert trapezoid to equivalent uniform load, and that would be WS over 3, okay, times 3 minus M square over 2. Ang ibig sabihin niyan, yung W is the floor load, no, yung 5.4. I-convert ko yung trapezoidal load into its equivalent, convert to equivalent rectangular load. So, solve ko yung W1. Okay, so solve ko yung W1. So, okay, W1 is equal to W, yun yung 5.4. 5.42492. Ano yung S? Yung S is yung shorter span. Ito, longer span, diba? Kung titignan mo ulit dito, ito yung shorter span. Ito yung longer span na 6 meters. Di bali ito yung shorter span, yung 4 meters. Okay, so 4 meters divided by 3 times 3 minus M square. 3 minus, ano yung M? M is the ratio. Ratio ng M ng S over L. Okay, ano yung ratio ng S over L dito? DEGH. Ito yun, DEGH. Ito yung M, which is 4 over 6 or 0.66, 4 over 6 na lalagay ko. 4 over 6 square divided by 2. Yan. So, yan yung formula. So, I will get now the equivalent uniform load galing sa trapezoidal load. So, 3 minus 4 over 6. 3 minus 4 over 6 square divided by 2. So, times 4 times 5.42496 divided by 3. So, I got 9.242524. That's already kilonewton per meter na. Okay. So if we will consider everything for beam DE, okay, so for beam DE, so just get the summation, no? So let's say again this is beam DE. Assume as simply supported. Again, yung length niya is 6 meters. So the total ultimate, when I say ultimate, that means yun na yung load factors, no? In-incorporate natin yung dead load, yung load factors for dead load and live load. So the total would be, 1 is here from the self weight and the CHB. Okay, number 2 is here. This is based from the rectangular tributary area. And third is here, based from the trapezoidal floor area. So ito total lang natin yan, yung 1, yung 2, tsaka 3. So that would be 14.232 plus 6.7812, then plus the 9.24. So therefore, the total uniform load for beam DE is 14.232 plus 6.7812. So that would be 30.2557. That's kilonewton per meter. So ito ngayon yung pinaka total load sa beam DE. Okay? So sa beam DE pa lang yan. So yan yung ina-explain ko sa inyo dati na sa theory of structures itinuturo kung paano na-identify, nalalaman yung mga loads. Kasi nung sa strength of materials pa kayo, 'di ba? Bibigyan kayo ng simple beam with uniform load, given na antimano yung uniform load. Pero you might be wondering paano ba na-solve yung mga loads na kilonewton per meter. So this is how we solve in detailed form, galing kung anong klaseng materyales, no? Tapos kung anong klaseng occupancy type, malalaman mo kung ano yung pinaka total uniform load. Okay, so next. Our next is for beam. How about for beam EF? So here, EF. Okay, so let's have it here. For beam EF, okay, so let's say here is the beam BF, EF, E, F. Diba ito yung longer span din? Longer span is 4.8 meters naman. Let's say, assume it's simply supported. So what would be the total uniform load? So yan yung tanong din sa kanya. W total. Okay, so ano yung maging W total niyan? So, ang W total niyan is almost the same din nung kanina. Ito pa rin. So, yung load na number 1, that comes from the self-weight kasi parehas naman ng beam size. Okay, tapos may CHB naman on top, directly on top of the beam din. So, kasama yan. So, that is for dead load. Tapos, yung floor load, ganito pa rin sa kanya. No? So, 5.4 pa rin siya. Kasi parehas naman yung mga dead loads niya tsaka live load pa rin. Ang may iba lang would be the tributary areas. Okay, so what would be the tributary areas? So, ano natin? So, what would be the tributary areas pagka sa beam EF? Tributary areas. Okay, hindi ba't meron tayong, okay, so, eto. So, di bali, ito ay trapezoid. Tapos ito rin ay trapezoid din. So dalawang trapezoid. Okay? So yung unang trapezoid, okay, so this is 4.8. Yung W dito is ganun pa rin yung W natin, no? So yung 5.4 pa rin. 5.42496. 42496. That's kilo Newton per square meter. Okay, tapos yung isa naman is trapezoid ulit. Okay, so ganun pa rin yung W. Okay, so ano yung pagkakaiba ng dalawang yan? Okay, ang magkaiba lang is yung trapezoid dito sa taas, ito yung S nya, yung S over 2, which is 1.25. Okay, so ito yung 1.25. So isabihin yung S nya is 2.5. Okay? 2.5 meters. Yung pangalawa naman, so this is 4 meters yung S nita. Kaya ito ay 2 meters. So ang S naman dito is 4 meters. Okay, so pag kinonvert natin siya, convert. Ito rin convert natin. Okay, so parehas trapezoid. So mako-convert natin siya sa uniform load. Again, ano yung formula? W1 is equal to WS over 3 times 3 minus M square over 2. Okay? So, solve natin dito yung W1. So, W is 5.42 496. Ang S niya is 2.5 divided by 3. Okay? Times we have 3 minus M. Ano yung M para dito? Ano yung M para dito? So, yun yung B, C, E, F. B, C, E, F. Ang M niya is 0.521. 0.521. Don't forget to square it. Okay, so yan yung W1. Okay, so dito naman sa pangalawang trapezoid, convert din natin siya. Okay, so isolve natin, so tawagin natin W2. So again, W2 is 5.42496. Okay? Times S. Anong S natin para dito? Yung 4 meters, no? 4 meters divided by 3 times 3 minus M. Ano yung M natin para dito? Diba ito ay para dito sa slab na to? So anong M natin sa EFHI? EFHI. Ang M natin doon is 0.833. 0.833 square. Okay, so there you'll get the W. So here, ang W1 natin is, so 3 minus 0.521 square. Okay, divided by 2 times 5.42496. 42496 times 2.5 divided by 3. So this is 6.16 1676. That's kilonewton per meter na. While this one, W2 natin dyan is 3 minus 0.833 square divided by 2. Okay, so times 5.42496 times 4 over 3. 8.3404 kilonewton per meter. Okay? So ano na ngayon yung total? So the total load for this case would be ano ulit? So we have the 14. So yung 14 322, then yung dalawang trapezoid, no? So yung dalawang trapezoid, so we have the 6.1 76 plus yung pangalawang trapezoid 8.3404. So the W total here becomes 6.16 76 plus 14.322. We have 28.82997. That's kilonewton per meter. So this is for beam EF. Okay? So yun yan. That is for beam EF. Now, paano mo isosolve naman yung sa girder? Okay, ano yung girder? Girder is a beam that carries another beam. So, parang yung beam na DE, nakatungtong siya dun sa girder BEH. Okay? Sorry, this should be BEH. This should be H. BEH. Girder BEH. Tapos yung beam EF din, yung support reaction niya sa E, ipapasa mo naman dun sa point na to sa girder BEH. So kung i-analyze natin yung girder BEH, ganito magiging itsura niya. So girder BEH. Okay, so for girder BEH, kunwari ito yung beam, ito yung girder. So ito yung support, ito yung support. Okay, so di bali ito yung 2.5 meters. Tapos ito yung 4 meters. So nandito. Dito yung 2.5, ito yung 4 meters. Okay, so ito yung reaction. Okay, so kakailangan mo yung reaction sa ED plus yung reaction sa EF. Yung reaction sa ED, yung reaction sa ED, ito yun. Yung reaction dito. Reaction sa ED. So makukuha mo naman yung reaction dyan kasi alam mo na yung load eh. Diba? Simple beam with uniform load. Tapos yung reaction sa EF, ito naman yun. Reaction sa EF. Makukuha mo naman yung reaction na yan kasi alam mo na yung load. Yung W total dito na 28. Okay? So, in short, alam mo na yung reaction na yan. Tapos, dito sa girder BEF, ano naman yung load dyan? So, kung titignan mo naman uli dito, BEH. So, meron kang triangular load dito. Diba? So, may triangular load tayo dito. Okay, so lalagyan mo ng triangular load dito. Ito yun, yung triangular load doon. Tapos dito naman, dalawang triangular load din. So, dalawang triangular load din. Okay, so dalawang triangle. Ito, 2 triangular load. Okay, isa, dalawa. Ito only 1. 1 lang to. 1 triangular load. Wala na kasi siyang load na kinakarga galing from this slab kasi one-way slab lang to eh. So di bali yung load lang na ikakargahin ng BE will comes from the triangle. Okay? Now, paano pag-convert ng triangle? Okay, so paano pag-convert naman ng triangular load? Kanina na-explain ko na kung paano pagkuha ng conversion ng trapezoid to uniform load. So, pagka trapezoid naman, pagka triangular load naman, so this is how we convert. Triangular load, pagka kinonvert mo sa uniform load, diba ito yung shorter span na? Shorter span yan eh. Ito yun, shorter span. So, 2.5. So, 2.5. Okay? So, the conversion would be simply WS over 3. Triangle lang. So, for this case, kung gusto ko itong i-convert sa triangular, kung gusto ko itong i-convert to rectangular, so that would be simply W1. Okay, W1 is equal to W. Ang W natin is, ano yun? 5.42496. Tapos yung S mo is 2.5 divided by 3. Okay, so ito yung for W1. Tapos yung W2 naman para dito, no? So diba dalawang triangle yan? Dalawang triangle. That is 5.42496 times, ang S naman dito is yung 4 meters. 4 meters divided by 3. Okay? So since dalawang triangle to, ita-times mo na lang. So times 2 triangles. Ayan, 2 triangles. So yung W1, W2 na. So di ba yung magiging effect niyan, magiging ganito na yung beam mo. So ito yung B, ito yung concentrated load, ito yung H, tapos meron kang uniform load. So ito yung W1, ito yung W2. Uniform load na. Tapos ito yung reaction ED at saka reaction EF. Ayan. So ganyan naman yung sa girder B, E, H. Okay? So that's it for the girder BH. Then last is how about for ABC? Asan yung girder ABC? Ito A, B, C. So ang mangyari dyan is for this span AB, may rectangular tributary area ka. Tapos for BC, may trapezoidal ka naman. So i-convert mo yung trapezoid to uniform load. Tapos, yung reaction dun sa girder BEH kanina, yung reaction dun sa B, magiging concentrated load naman, siyang mo ipapasa naman dun sa point B ng girder ABC. Okay? So, ganun ang mangyayari dun sa girder ABC. Tapos, paano naman pagka sa column? O ano yung magiging column load? So, for column A, ang magiging force na kinakarga ng column A would be yung reaction sa girder na to. Reaction sa girder na to at this point, yun yung magiging column load sa A. Tapos, kukuhain mo rin yung reaction dito sa girder na to, sa ADG. Yung reaction sa A, galing sa ADG, yun yung ipapasa mo rin concentrated load doon. So, yung reaction galing dito sa girder na to, tsaka yung reaction galing sa girder na to, pagsasamahin mo, yun yung magiging total concentrated load sa column sa A. And etc. etc. para sa column C, column I, tsaka column G. Okay, so that is how we analyze or transfer or calculate structural loads in a frame. Okay, so I hope you learn out of these calculations or solutions. And if you have just questions, just send me your questions. Okay, so thank you.